Hi everyone, Cedric here. Today I'm going to show you something that completely transformed how we handle massive data sets with RAG agents. So first of all, let me show you what we can do with this type of RAG agents connected to an MCP server and connected to Claude.ai. So this can look through different databases. We can send WhatsApp messages to check candidates' availabilities or references. We can do the same with emails, SMSs, create candidate summary, etc. So this is designed to be the ultimate recruitment assistant. So when we go into Claude.ai, we can make a query like this one, get our top 10 yacht candidates for a 60-meter yacht. And this is going to look through the databases using the reranking and categorization system. And this is going to return a list of the most relevant candidates. And then from there, we can make other requests like send SMSs, summaries, etc. So this is designed to really speed up the speed to fill for recruitment agencies. So let me just show you how this is built, how this is currently built, and this is not the most easy way. Now I'll show you how we can make it a lot faster and not as good, but as good using the n8n new re-ranking feature. First of all, what you need to understand is that when you are embedding documents or when you are embedding text inside the vector store, the chunk, the content is a chunk that gets converted into a suite of numbers. And then when you are asking the question also gets embedded, and then you get the result based on the similarity. So the similarity doesn't necessarily mean relevancy. There is no intelligence in it. The intelligence is inside the AI agent or inside the LLM, but you need to help the process as much as possible. So first of all, when you are embedding the data, you need to do what we call the contextual retrieval. So you'll provide a short summary of the actual chunk and then the chunk itself. Everything gets converted into a suite of numbers. And here you also need to have a full text search capability. This is for keyword search and this is for semantics. Really important because I'm going to show you a concept which is called hybrid search, which combines the power of semantic and the power of keyword search in order to retrieve the results. So let me just show you how this is built. So this is connected to an MCP server. And here we have the query. So the query is coming from the MCP server or coming from the AI agent. You can use either or you can even use an MCP server connected to an AI agent. So we make sure that the query is unified here. So we can use JSON.query. And then in the upper branch, we are going to process the semantic search. In the lower branch, we are going to convert this search into a web search and then use that search in order to look for relevant keywords inside Supabase. So let me just show you the execution. So here we are looking for a chief engineer 3000, a limited male with a specific experience. And here we are returning 150 rows. We are using Match Lighthouse documents. So this is the query name, really important. If you don't use that, this is not going to work. Or you can use any name, but you have to have a function. And here, as you will see, this is returning everything, including the metadata. Metadata is super important. We have a dedicated column for metadata. And here, this is also providing a score. As a next step, we have this query builder, which is a simple LLM node, which is basically converting this query into a web search query, like you would if you were to do complex searches in Google. And here we have the Supabase. So here we are searching through the the relevant rows, so which might contain the, I lost the connection here because this is actually pulling a lot of data. I'm going to continue with the video. It's not going to affect the system. Here I'm going to show you the BM25. So BM25 is an algorithm which will calculate the relevancy of those chunks based on the keywords. And here we have the BM25 score and the relevancy percentage. The next step, we merge everything, and then we merge n format so that we have the query. We have an ID, important because the re-ranking is going to use this ID in order to pass the actual content. And here we have the structured data, including the metadata. Now I'm going to show you the re-ranking systems. We use Cohere. So we make a post request to this URL, make sure that the credentials are set up this way. So authentication, use predefined credential type. And here you will choose Cohere API, and here you will set your new credentials. So create new credentials and just paste the API key in here. Don't do a lot of YouTubers do, so pass the API key here inside the header. This can get intercepted by hackers. You don't want your API keys to be exposed. When you do it this way, the API key gets encrypted. So next we are going to use sendBody JSON, and we are going to use Rerank v3.5. Here we pass the query. This can actually check the relevancy based on this query. Top n, so this is 50, and documents, which is basically the content of those chunks. The next step, we make sure that we rehydrate, sorry for the barbarian term. So rehydrating just means that we use the index, and this index was set previously in order to retrieve the content based on this index, and then we make sure that everything is sorted by relevancy, and we make sure that this is obviously connected to the MCP server or to the AI agent, and this is basically returning all of this data, and the brain, the AI agent or the LLM can use that and return the result. Easy. Now I'm going to show you the easy way to do that. Here you can see in our MCP server, we have tools connected to Supabase, and two of those have the Reranker by Cohere. Two don't. When we use small data sets, we don't need to re-rank results because this is accurate. But when we have large data sets, we need to make sure that there is an additional check. So to do that, it's simple. We toggle this on, re-rank results. And here we'll click this plus button. At the moment, there is only one option, so Cohere. And then the model is Rerank v3.5. And that's pretty much all there is to it. It's simple. As I've mentioned, this method is lacking the full text search. I prefer to use the hybrid method. This one here is that combines the semantic search with the full text search and the re-ranking system. But if you are just beginning and if you don't want to start messing around with stuff like that, you can do it the easy way, and this is already 10 times better than it was up until last week.